So today, this is your lecture number 3. Lecture number 3, electrostatics. Okay, select this pen. Fine. And okay, so we have discussed about quantization of charge, right? So in the last lecture, we have discussed that charge on the body is always one type, which is simply equals to n, right? Where n can be 1, 2, 3, 4, and it cannot have any other values. Fine. Okay. Now we'll discuss today about the charging methods, right? A body can be charged in 3 ways. You can charge a body in 3 ways. But before understanding about the charging methods, let us discuss 1 or 2 questions based on quantization of charge, right? Like suppose if question says that 10 raised to if 10 raised to 9 electrons are removed every second from a body, find the time taken to establish a charge of 1 coulomb. It's your textbook. I think this is your second example. Second example of your textbook. See what the question says. If 10 raised to 9 electrons, 10 raised to 9 electrons are removed every second, that is in 1 second, 10 raised to 9 electrons are coming out from a body. So to calculate the time taken to establish a charge of 1 coulomb, if you want to establish a charge of 1 coulomb, what will be the time taken to establish a charge of 1 coulomb? Okay, so how to solve this? Let us solve this. First of all, for to establish a charge of 1 coulomb, how many electrons are to be removed from the body? We'll find it this way. First, we'll calculate that in order to establish a charge of 1 coulomb on a body, how many electrons are to be removed from that body, right? And then again, we can cross multiply. See, like by using the formula Q equals to Ne, right? I'll calculate N, Q by T. Q is 1 coulomb, charge of electron is 1.6 into 10 raised to minus 19. So this comes out to be 0.625 into 10 raised to 19. Or you can say 6.25 into 10 raised to 18. This many electrons are to be removed to establish a charge of 1. Now, if 10 raised to 9 electrons are removed in 1 second, so in order to remove 6.25 into 10 raised to 18 electrons, time taken is, let us say it is T. Cross multiply T into 10 raised to 9 equals to 6.25 into 10 raised to 18. So from this we'll be able to calculate time. So this will be the time taken to remove, or this is the time taken to establish a charge of 1 coulomb. Got it? See how we have done this sum. First we'll calculate the number of electrons which are needed to be removed out from the body to get a charge of 1 coulomb. So we have calculated the value of number of electrons, right? So that comes out to be 6.25 to 10 raised to 18. Now if in 1 second 10 raised to 9 electrons are removed, so total this many electrons need to be removed, so time taken will be cross multiplied. Got it? Clear? Now let us discuss the charging method of a body. That means how we can charge any body. See, there are actually 3 ways to charge any body. Charging by friction, charging by conduction, charging by induction. These are the three methods you can charge a body. Okay, see, charging a body. Three ways. First one is friction, another is conduction, third one is induction. Okay, let us discuss first one. Friction, that means when two woolen jackets touch each other, a charge will be transferred from one body to another. That is again charging by friction. When you are rubbing a piece of paper with dry hairs, and then you are placing it closer to the bits of paper, then again the bits of papers are found to be attracted. So this method is also known as charging by friction, right? If you are making any strip of paper and if you are bringing it close to your TV screen or laptop screen, you will see that the strip gets attracted towards the screen. So these are all the charging methods of friction, right? That means charging method of friction means when two bodies, if they are rubbed with each other and if a body is being charged, then that is known as charging by friction. Known as charging by friction. Clear? Next example is when a when a comb is rubbed with dry air and it is found that it will attract the beads of paper, right? So this process of attracting the beads of paper, that is known as charging by friction. Okay, so see students, finally there are three methods of charging a body: charging by friction, charging by conduction, and charging by induction. To charge the body with the help of friction, that means when two woolen jackets are rubbed, or when two woolen jackets get rubbed with each other, then a charge is flown from one body to another. That is known as charging by friction, right? When you are rubbing a comb with your dry hair and then you are placing it closer to the bits of paper, you will see that the bits of papers are attracted towards the comb. So these are all the methods where a body can be charged with the help of friction. These are all the examples where we'll see that the body is charged with the help of friction. Now, the second method, that is to charge the body with the help of conduction. That means charging with the help of conduction. See, charging with the help of conduction. Conduction is a method where you will charge a body by making a physical contact with another. Right? That means charging a body by making physical contact with another body. Physically make a contact with another body and charge the body, then that method is known as charging by conduction. Just we'll take a look about this method, see how to charge the body with the help of conduction. Okay. Suppose sphere, say it is having a radius r, right? It is a, let us say, neutral sphere, and this is another sphere, say of same radius r. That means both the spheres are identical. Let us say this sphere is being charged. It is having positive charge. It means we have removed electrons from this sphere. Let us say this sphere as A and this sphere as B. So sphere A is positively charged, right? Let QT be the total charge. Okay, and B sphere is electrically neutral. Now if I am joining both the spheres with the help of a conducting wire, there is a conducting wire. Okay, so now we'll observe that the electron, see, this is the neutral body. Neutral means it will have equal number of plus, equal number of minus, right? Right? Neutral means the body will be having equal number of plus and equal number of minus. So few electrons from this body will be transferred to A because A is positive charge. So few electrons will be attracted towards the sphere A. Got it? This is a B sphere is electrically neutral. So it will have few electrons which will be attracted towards A because A is positively charged. So few electrons from B will flow towards A. So then again B will also be positive charge. Clear? So B will now have a charge Q by 2 and A will also have a charge Q by 2. So B, which was initially neutral, is now electrically charged by making a physical contact. Right? Clear? So now A and B, both the bodies are having a charge of Q by 2, Q by 2. Both the bodies are having a charge of Q by 2, Q by 2. Got it? Once again, B was electrically neutral before and A was positively charged. It was having a charge of Q total. When B is made in contact with A with the help of a conducting wire, that means conducting wire is making a physical contact between B and A. It is found that few electrons will be attracted from B and will be moving towards A. Right? So finally, the process will stop once when both the spheres A and B, both the spheres A and B will have a charge of Q by 2, Q by 2. That means charges will be equally divided. This is possible only when spheres are identical. This should be clear to all of you. Right? That means it is not necessary that always charge will be equally divided. Here the charges are equally divided between both the spheres because both the spheres are identical. Clear? If they are not identical, then charges will not be equally divided. Clear? That means what if one sphere is having a radius r1 and another is having a radius r2? In such cases, charges will not be equally divided. Suppose one is having a radius r1. Another sphere is having a radius r2. Let us say r2 is less than r2. Right? Now if they are made in contact with each other, suppose this was having a total charge Q total and this was say neutral before it. Now I made a physical contact. Okay. So physical contact, if I am making, then one will be losing electron and another will be gaining electron. Clear? That means from the neutral body, electrons will be moving to the positively charged body, right? But the problem is here the radius is r1 and this is r2. So after the process gets over, this will get a charge q1 equals to q total into r1 upon r1 plus r2. This is the formula to calculate the charge on the body when the spheres are not identical. You understanding the point? This was the case where spheres were identical, so charge was equally divided between them. But in this case, the spheres are not identical. One is having a radius of r1 and another is having a radius of r2. So Q2 will be Q total into R2 upon R1 plus R2. This is how we will calculate the charge when spheres are not identical. We'll discuss and of course we'll derive this formula, but after few lectures because you need a concept of potential which is explained later on. Right? So all the students please note down this formula. This formula is to calculate the charge on the body because of conduction, but when the spheres are not identical. If they are identical, you can directly put Q by 2, Q by 2. So in this case also, if R1 is equals to R2, right, substitute here. Let us say, suppose Suppose both are having same radius. That means let us say R1 equals to R2 equals to R. R1 equals to R2 equals to R. Okay. So then if R1 equals to R2 equals to R, substitute the value. Q1 equals to Q total into instead of R I let it as instead of R1 I let it as R. R1 plus R2, so that will be R plus R. So this will be Q total into R upon 2R. R gets cancelled. See, Q by 2. So with the help of this formula, we can calculate the charges on the spheres, whether the spheres are identical or they are not identical. So in this lecture, students will discuss two methods to charge a body, and in the next lecture, we'll be discussing about charging by induction. It's a bit lengthy method, and we'll also understand what is earthing and what is grounding. Okay, thank you.